Consider sequences of positive real numbers of the form x 2000 y ... in which every term after the first is one less than the product of its two immediate neighbors. For how many different values of x does the term 2001 appear somewhere in the sequence? Okay, so we've got x, 2000, y, and then we keep going like that. And they're saying that there's a fundamental property that every term after the first is equal to one less than the product of its immediate two neighbors. So that means if we take 2000, 2000 is equal to one less than the product of its two neighbors, like this. Okay? So I hope you understand that. Every term after the first is one less than the product of its two immediate neighbors. Okay? So, let's go with that. This is term 1, this is term 2, this is term 3, and we'll try to find a bunch of terms here. Hopefully we'll see a pattern, and that's usually the type of scenario in these kinds of questions. I'll try until T7 and then I'll run out of patience. All right, so for the first one, I've got bring the 1 over 2001 is equal to xy, and therefore y is equal to 2001 over x. Okay, so let's try to make this neat. Let's not make it messy. Let's use different colors. X is fixed as x, all right? 2000 is fixed as 2000, but y is 2001 over x. All right? Okay, so far so good. So that was T3 that we just found. Okay, now let's figure out T4. How do we figure out T4? Well, according to our formula, every time you have a term like T3, it's equal to one less than the product of its two neighbors. So its two neighbors are T2 and T4, like that. Okay? So that means T3, which we already figured out is 2001 over x, is equal to T2, which is 2000, times T4, minus 1. So do a little bit of algebra here, and you're going to get 2001 over x plus 1 is equal to 2000 T4, like that. So this looks like 2001, common denominator is x, like that, and 2000 T4. So T4 is 2001 plus x over 2000x. Okay? So where do I squeeze that in there? Maybe I'll need a little bit more space. So I've got 2001 plus x over 2000x for T4. So the next one we are going to figure out is T5. So we were going to have to go T4 is equal to T3 times T5 minus 1, like that. T4 is 2001 plus x over 2000x is equal to T3, which is 2001 over x, T5 minus 1. So you're going to have 2001 plus x. If you add the 1 to that side and get a common denominator, it'll be 2000x all over 2000x, like that. And this equals 2001 over x T5. So this looks like 2001 plus 2001x over 2000x times x over 2001 is equal to T5. All right. And let's see, does this simplify in any way? if you factor the 2001, you get 1 plus x, and x over 2000 x and 2001. Okay, great. The 2000s go and the x's go. So T5 is left with just 1 plus x over 2000. All right. So 1 plus x over 2000. Moving right along. Now we get to, what are we up to now? We have to find T6 next, right? So T6 we will have to use T5 is equal to T4 times T6 minus 1. T5 is 1 plus x over 2000. T4 is equal to 2001 plus x over 2000x. And T6 minus 1, like that. So bring the 1 over and get a common denominator, which will be 2000, like that. And then this is 2001 plus x over, this is a 2000, 2000x, T6. So we've got 2001 plus x over 2000 times cross multiply 2000x over 2001 plus x is equal to T6. And looks like the, oh, this is great. This actually simplifies to just x. All right, great. So I am going to get a pattern. One more, T7. I know this is torture, but it's okay. So one more and we got, let's see, we're trying to find T7, right? So T6 is equal to T5 times T7 minus 1. X, T5 was, what was T5? 1 plus x over 2000. T7 minus 1. So you got x plus 1 is equal to 1 plus x over 2000. T7. And therefore T7 cross multiply 2001 plus x. So T7 is equal to just 2000. Perfect. So we indeed have a pattern. Okay? It's going to repeat. X 2000, 2000 over x, 2001 plus x over 2000 x, 1 plus x over 2000, and then it'll be x 2000, and it'll just keep on going like that. Now, what are they asking in the question? For how many different values of x does the term 2001 appear somewhere in the sequence? What is the value of x if we set these terms equal to 2001? All right, we can figure that out. So the first one, if we set it equal to 2001, we're done. So that pretty much takes care of the first one. How about if we let the second one, 2001 over x equal to 2001? Well, that would mean that x is equal to 1. So this is one value, this is another value. How many different values of x does the term 2001 appear somewhere in the sequence? All right. So if we let x equal to 2001, the term 2001 will appear in the sequence. It will be T1. If we let x equal to 1, this T3 becomes 2001, and therefore the term 2001 will appear in the sequence. All right, so I hope you understand. So again, T4, we got to let that equal to 2001. Probably have a little bit more algebra here. So we got 2001 plus x is equal to 2001 times 2000 x, like that. 2001 is equal to 2001 times 2000 x minus x. Factor out the x and you'll get 2001 times 2000 minus 1, and therefore x is equal to 2001 over 2001 times 2000 minus 1. Okay, so this is another value of x for which the term 2001 will appear in the sequence. So that's a third value. And we've done T1. T2 is fixed, so we can't do T2. We've done T3, we've done T4, and let's see what we get for T5. So T5 is 1 plus x over 2000, and we set that equal to 2001, and therefore 1 plus x is equal to 2001 times 2000, and therefore x is equal to 2001 times 2000 minus 1. So here is a fourth value. So when x is equal to 2001, this expression, T1, will become 2001. When x is equal to 1, T3 will become 2001. When x is equal to this big long number, T4 will become 2001. And when x is equal to 2001 times 2000 minus 1, T5 will become 2001. So we've got 1, 2, 3, 4 values of x that make the terms equal to 2001. And therefore the answer for number 24 is number 25.